Alright guys, welcome to your 30th video, and in this video I want to talk to you guys about one of the more interesting topics in physics, the law of conservation of energy. Now, if you looked up this law in a textbook or online, it would probably say something like the total energy at the end of any event is equal to the total energy before the event. But that's kind of a confusing definition, so you may have heard it like this. Energy can neither be created nor destroyed. Basically, energy can't come from nowhere. It had to come from some other place. It was just converted into something else. So why is this important? And I thought we were talking about potential energy and kinetic energy. So what the heck is all this crap? Well, I want to show you guys an example of how potential energy can become kinetic energy. Basically, remember when I said there was an apple that was on a tree and it had the potential to turn into energy, but right now it was just sitting there doing nothing? Well, the type of energy it had the potential to become was in fact kinetic energy. Now, whenever we look at real life examples, you're going to notice a little fluctuation, a little loss in energy in some cases, and I want to explain to you guys why that is. So this is a little side note. Take the example of a pool ball, and I'll say that this is the cue ball and this is the 8 ball. So remember when I said that whenever the cue ball hits the 8 ball has it's pretty much going to start moving, and there's going to be a transfer of energy. The energy from the cue ball is going to go to the 8 ball. Now, if you run some calculations and measure everything, you would notice that the 8 ball does not absorb 100% of the energy from the cue ball. The 8 ball is going to move at a velocity slightly slower than the cue ball. So you're saying, wait a minute, if the cue ball was supposed to transfer its energy to the 8 ball and the 8 ball isn't moving as fast, then where the heck did the energy go? Because the law of conservation of energy says it can't be lost. You can't just get rid of energy in the universe. Well, some of this energy turns into kinetic energy and the 8 ball starts moving, but aside from that, much of its energy goes into other forms of energy, specifically heat energy and sound energy. That's why you hear a noise whenever the balls are going to hit each other, and also they're going to produce a certain amount of heat. So even though whenever you're calculating strictly the motion and velocity of these balls, it's going to look like some energy is lost, and these are going to be in real life examples. In fact, the law of conservation of energy is not broken, it's still valid. They just go to different forms of energy. So remember that energy can be converted into different forms. It just can't be created nor destroyed. So now let's go ahead and take a look at an example of when indeed this would be useful. Let's go ahead and take a look at an energy calculation. So say that you were standing on a bridge, and I guess the bridge looked a little bit something. I'll just make it really simple. This is a bridge, and what's below? A sidewalk, I guess. This is a sidewalk, and I guess this is a building. And hey, if we're going to get really creative, I say that this building sells tuna. Why not? It's my example. So you were standing on top of this building that sold tuna, and you had a big old meatball in your hand. Why? I don't know, man. It just, I don't know. It's my example. This is the first thing that comes to my head whenever I'm trying to think of an example. Meatballs and tuna. How bad is that? So let's go ahead and first take a look at this energy calculation. This meatball right here, it has a mass of 5 kilograms. Now, in addition to that, how far are you standing off the ground? Well, we will say that you are standing off the ground 20 meters. So this meatball is 20 meters in the air with a mass of 5 kilograms. So what we need to do is we need to figure out how much kinetic energy this meatball is going to have whenever you drop it and it hits the ground. Well, in order to figure that out, since kinetic energy you need mass and velocity, we don't have the velocity yet. So how are we going to figure out the kinetic energy? Well, the first thing we need to do is we need to figure out what we can, in this case, the potential energy. So the potential energy, as we know, equals, well, it equals the weight of an object times height. So in other words, since we don't have the weight, we only have the mass. Mass times the force of gravity, that's going to give you your weight. And you take this and you multiply that by the height. So the potential energy of this meatball equals 5 kilograms times the force of gravity. That's how fast that's how you tell how fast this meatball is gonna be sucked into the earth with a force of 9.8 meters per second squared. And you take this and you multiply it by the height, which is 20 meters. And whenever you do this, you find out that when you are holding a meatball on top of a 20-meter building, and this meatball has a mass of 5 kilograms, it has a potential energy of 980 joules. You probably don't care about that. You're probably just hungry and just want to eat that meatball. But that's important because now what we can do is we realize that the kinetic energy right before it hits the ground is going to be equal to 980 joules. Why? Because then, right before it hits the ground, it's going to be moving instead of in your hand and still. So furthermore, what we can do is we realize that the kinetic energy right before it hits the ground is equal to 1/2 mass times velocity squared. So we know a couple pieces of this equation, the kinetic energy, the mass. Now we can figure out what's the velocity of this object right before it hits the ground. Well, the kinetic energy, since the law of conservation of energy is converting this from potential to kinetic, is going to be 980 joules right before it hits the ground. Now this is equal to 1/2 the object's mass, which is 5 times its velocity squared. So what we can do now is figure out 5 times 1/2. Whenever we take that and throw it over 980, we get 392, and this is going to be equal to its velocity squared. So if you were wondering, whenever I drop this meatball from this building, how fast is it going to be moving right before it hits the ground? Well, if we figure out this equation and take the square root of both sides, we get an answer of, maybe I shouldn't write it right there. Its velocity right before it hits the ground is equal to 19.8 meters per second. So how awesome is that? Only knowing the mass and the distance from the ground, we can not only figure out its potential energy, its kinetic energy, but we can also figure out the velocity of the meatball right before it hits the ground. So many pieces of information using these simple calculations or formulas in physics. So hopefully you guys understand a little bit about the law of conservation of energy, how potential energy often becomes kinetic energy, and also how you can, with few pieces of information, figure out a whole lot of crap. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video.